The Y parameter of a two-port network are Y is equal to 5, 3, 1, 2 Siemens. A resistor of 1 ohm is connected across as shown in the figure. The new Y parameter will be. So we have to find out the new Y parameter. Okay, so for that this is the old Y parameter. It is given in the question. It is 5, 3, 1 and 2. Okay, so from here I am going to write Y11. This is Y11 and this is Y12. This is Y21 and this is Y22, right? So Y11 is equal to 5, Y12 is equal to 3 and Y21 is equal to 1 and Y22 is equal to 2, right? So the equation of a Y parameter is I1 is equal to, no, I am not Shivangi. So I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. Please keep this in your formula book. This is an important equation. So that is it, and with that I am just going to draw this equation. Okay, so from here I can we can see that this I1 is equal to Y11 V1 plus Y12 V2. From here I can conclude that our I1 is being divided between Y11 V1 and Y12 V2. So I am just going to draw this equation in circuit form. So I1 is coming and I1 is being divided between Y11 V1. Okay, so let this be Y11 V1. Okay, so this is our V1 and the next one is Y12 V2, but here this is our port 1. Okay, so Y12 V2 is actually depending upon V2. Port 1 if it actually this is depending upon our port 2's voltage, right? So V1 is port 1's voltage and V2 is port 2's voltage. We are talking about two port network. So this is 1 dash first port and this is the second port and this is V2 and this is V1. So in this equation Y12 V2 is a dependent source, current source. So I am going to draw it like this. A dependent current source looks like this, right? Equal to Y12 V2. Just because it is dependent, that is why I have not written it as drawn it as a resistor. Okay, so that is about first port and let me draw the second port. If I am drawing the second port, see this, I2 is divided between Y21 V1 and Y22 V2. Here also I am talking about the second port, but this one is a dependent source, right? Dependent upon the voltage in the first port. So it will be like this. Y21 V1 plus Y22 V2, right? This I2 is being divided between Y22 V2 and Y21 V1 and this is our V2. So this is the general format of a Y parameter if I am drawing it in the circuit form. But in the question it is given that a 1 ohm is being connected extra. Okay, this is actually 5, 3, 1, 2 can be drawn as like this. But in the question 1 ohm is actually added now. So I am going to add a 1 ohm. So I'll take another color because this is added. So this is our new 1 ohm. Okay. And the question it is asked, we have to now find out what is our new Y11, Y12, Y21 and that is our Y new. We have to find it out. Okay. So now I have to write a new equation for I1 and I2 because there is one more branch. In the first figure, I1 was being divided between this branch and this branch only, but now it is divided between is going to this branch as well. Likewise, I2 was being divided between this branch and this branch, but now it is being divided, it is going to this branch as well. Okay, so the voltage over here is actually V1 itself, right? The voltage over here is V2 itself, and the current flowing through our 1 ohm is V1 minus V2 divided by 1. Okay, so I can write V1 minus V2. So this is in this direction, and considering I2, this current is coming from this direction. So it will be V2 minus V1. Our current always flows from high potential to low potential. So keeping that in mind, if I am considering the second port, it will be V2 minus V1. The current will be V2 minus V1. If I am considering the first port, it will be V1 minus V2. Okay, clear? So now I am going to write the equation for I1. Okay, if I am writing the equation for I1, I1 is equal to let's see, I1 is divided between Y11 V1 plus Y12 V2 plus one more term is coming, V1 minus V2. Okay, now I2 equal to, I2 is divided between Y21 V1 plus Y22 V2 plus one more term is there, V2 minus V1. Okay, so these are the new two equations. Okay, so I'm going to simplify it. I'll draw the, I'll write that once again. I1 equal to Y11 V1 plus Y12 V2 plus V1 minus V2, and I2 equal to Y21 V1 plus Y22 V2 plus V2 minus V1. Okay, now we'll take V1 terms together. So that is Y11 V1 plus V1, and taking V2 terms together, Y12 V2 minus V2. Okay, so we'll get Y11 plus 1 into V1 plus Y12 minus 1 into V2. Okay, so I can write I1 is equal to Y11 plus 1 into V1 plus Y12 minus 1 into V2. Okay, so the general form of the equation was Y1 is equal to Y11 V1 plus Y12 V2. So instead of that, we have, instead of Y11 we have Y11 plus 1. So this is our new Y1 dash. Okay, and this is our new Y12 dash, right? And taking I2, taking the V1 terms only, we will get Y21 V1 minus V1 plus Y22 V2 plus V2. Okay, so we will get Y21 minus 1 into V1 plus Y22 plus 1 into V2. Okay, so this will be our new Y21 dash, and this is our Y22 dash. Okay, so now we can take it. So Y new, okay, Y new equal to Y11 dash equal to, actually our Y11 was, it is given in the question that it is 5, 3, 1, 2. Our new Y11 dash is 5 plus 1, that is 6. And Y12 dash is Y12 minus 1, that is 3 minus 1, that is 2. And again Y21 dash is Y21 minus 1. Y21 is 1, 1 minus 1 is 0. And again Y22 dash is Y22 plus 1, that is 3. Okay, so this is our new Y parameter matrix after putting a 1 ohm across the two ports. Okay, Now let us do the next question. Excuse me. Okay. Okay. For the circuit shown in the figure, okay, this is the question. For the circuit shown in the figure, the transfer function is given as h of j omega equal to okay, right. H of j omega is equal to V0 of j omega divided by Vs of j omega, which is equal to 0.6 into 1 plus j omega divided by 12 and divided by 1 plus j omega divided by 20. So what is the value of inductance in Henry? That is the question being asked here. Okay, we have to find out the value of inductance, that is our L. Okay, so I am just going to write the transfer function of this particular circuit now. So it will be V0 of j omega divided by Vs of j omega. Okay, so the transfer function is 60 plus j omega L divided by 60 plus j omega L plus R, right? So this is the transfer function. So if I am writing it now, V0 of j omega divided by Vs of j omega equal to 60 plus j omega L into 60 plus, okay, I will write 6 plus j omega L divided by 60 plus R plus j omega L, okay, which is equal to, in the question, it is in the form 1 plus j omega divided by 12 and 1 plus j omega divided by 20. So I'll take that in that form only. I'll take 60 outside, then it will become 1 plus j omega L form, right? So j omega L divided by, here also I have to take 60 plus R outside. So it will be 1 plus j omega L divided by 60 plus R. Okay, pardon me. So instead of that, I'll take 60 outside, 1 plus j omega L. I have to cut this to 60. So I'll take 60 from both the upper and downside. Okay, 1 plus R divided by 60 plus j omega L divided by 60. Okay. So it will become 60 into 60 cancel. So what will be remaining is V0 of j omega into Vs of j omega equal to 1 plus j omega L divided by 60 plus R divided by 60 plus j omega L divided by 60. But there was another thing here also, 0.6. So I am going to multiply 0.6 and divide 0.6. Okay. So if I am doing that, I'll get 0.6 into 1 plus j omega L divided by, I am taking it inside, I'll get 60 into 0.6. What is it? 3.6, right? No. Okay. 60 plus R divided by 60 into 0.6 plus j omega L divided by 60 into 0.6. Okay. So we will get 0.6 into 1 plus j omega L divided by 0.6. I'll get 0.6 plus 0.01 R plus j omega L okay, there was a 60 here, right? I'm so sorry. Okay, divided by 100. Okay, so comparing these two equations, we get 1 plus j omega L divided by 60. Instead of j omega divided by 12, we have 1 plus j omega L divided by 60. So I am going to substitute that. So j omega divided by 12 equal to j omega L divided by 60 here. Okay, so j omega cancel out. We will get L is equal to 5 Henry. Now let's do the next question. Half wave rectified sine wave shown in the figure, shown in the waveform, then RMS value. We have to find out the RMS value. Okay. So the RMS value, to find out the RMS value is actually equal to root of RMS value is actually what? Take the square first, then find its mean and then find its root. Okay. So that is the RMS value. For that we are going to find out our VRMS. So our time period here is, it is repeating itself after 2 pi, right? So time period here is 2 pi and it is a sine wave. It is already given that it is a sine wave. So I am going to write the RMS equation. VRMS is equal to root 1 divided by 2 pi integral 0 to 2 pi v square t dt. Okay, which is equal to VRMS equal to 1 divided by 2 pi root 1 divided by 2 pi integral 0 to pi. From 0 to pi it is a sine wave, right? It is a sine wave. So I can write it as, it is having an amplitude, a sine wave having an amplitude of 5. So it is 5 sine t the whole square, v square, it is square, please don't make that mistake, it is square, plus integral pi to 2 pi, it is 0, right? No waveform is there, it is 0 the whole square into dt. Now we have to simplify it. So it is 1 by 2 pi, let it be like this, and 0 to pi 25, I am taking 5, I was 5 square outside, that is 25 into sine square t dt. Okay, now 1 by 2 pi, take 25 outside. Okay, so instead of sine square t, we can write it as 1 plus cos 2t divided by 2 into dt. Okay, now this is okay, I'll write the rest of them here. Okay, now it is 25 by 2 pi integral 0 to pi 1 by 2 dt plus integral 0 to pi cos 2t divided by 2 into dt. Okay, so I am going to integrate it. we'll get 25 divided by 2 pi, and the integration of 1 is t, right? So t from 0 to pi plus 1 by 2 into sine 2t divided by 2, 0 to pi, okay? So it will be root 25 divided by 2 pi 1 by 2 into pi minus 0 plus 1 by 2 into 1 by 4, let it be 1 by 4 into sine 2 pi minus sine 0. So this will be equal to 0 because sine 2 pi and sine 0 are 0. So completely this will be gone, and the rest of them will be 25 divided by 2 pi into pi divided by 2, okay? So it will be equal to root 25 divided by 4 or 5 divided by 2 or 2.5 volt. So this is the what Vrms value, okay? 2.5 volt. Okay, let's do the next question. Yeah, it is sine square t. What's the problem? I solved it like that only. Instead of sine square t, I wrote it as 1 plus cos 2t divided by 2 and then integrated it. Now the next question. Find the transmission parameter A Okay, I have corrected it as 1 minus cos 2t divided by 2. It was my mistake. I wrote it as 1 plus cos 2t. It is 1 minus cos 2t. Thank you for reminding. Now let's do the next question. So in the next question, find the transmission parameter A for the two-port network shown in the figure. Okay, for this also I will give a formula. V1 is equal to, for A parameters or for ABCD parameters. So this is the equation. V1 is equal to A V2 plus B I2 and I1 is equal to C V2 plus D I2. Okay, so this is a formula for ABCD parameters. So to find out A, the equation is V1 divided by V2 when I2 is equal to 0, okay. So when I2 is equal to 0, this term will be cancelled out. So what will be remaining is V1 is equal to A V2. From there we will get A is equal to V1 divided by V2, okay. And from the figure itself we will have to find out our A. So it is given that I2 is equal to 0. So I2 is equal to 0. So only current present here is I1. Okay. Now I am going to write the equation, mesh equation on both the ports. So I am writing the mesh equation over here. If I am writing it, I will write V1 minus 10 I1 minus 20 I1. Because in both of these resistor, I1 will be the only current that is going to flow. So we will get V1 minus 30 I1 equal to 0 or V1 equal to 30 I1. Okay. And in the second mesh, we can write V2 plus 3 I1 because it is increasing potential. Okay. Negative to positive. That is why I wrote it as plus. Okay. So V1 plus 3 I1 minus 20 I1 equal to 0 or V2 equal to 17 I1. Okay, 17 I1, and now we have to find out. To find out A, we have to divide these two, right? V1 and V2. So we'll get 30 I1 divided by 17 I1. Okay, 30 I1 and I1 cancel. So 30 divided by 17, we'll get the answer 1.76. Let me see, 30 divided by 17, we get 1.76. Okay, no unit is there, it is a gain, inverse gain. Okay, okay, now let's do the next question. In this question, the input impedance Z of the following circuit at omega is equal to 10 raised to 3 radians per second is asked. Okay, so our input impedance is asked here. And I am going to write this in j omega format. So in the j omega format, capacitor becomes 1 divided by j omega c, and inductor becomes j omega L. Okay, so our capacitor will be equal to 1 divided by j into, instead of omega it is given, it is 10 raised to 3 into c. C, it is 10 microfarad. So we will get 1 divided by j into 10 raised to minus 2, or 100 divided by j, and j into j will get minus 100 j. So capacitor can be written as minus 100 j, and the inductor will become j omega L, right? So that is j into 10 raised to 3 into 20 into 10 raised to minus 3. It will be equal to 20j. Okay, now I am going to redraw the circuit. Instead of 10 microfarad, I am going to write it as minus 100j, and resistance is as it is, 10, 14, and inductor becomes 20j, and this is 15 ohm. Okay, so that is it, and we have to find out our Zn. Right, so if you can see, the Zn is 14 and 20j are in series. So 14 and plus 20j, and that is in parallel with our 15 and 10. 15 and 10, as you can see, they are in turn parallel with each other. So 10 parallel 15, that is 14 plus 20j is parallel with 10 parallel 15, and that is in series with 100j. So plus minus 100j. Okay, so I'll write 14 plus 20j parallel with 10 parallel 15. I'll write R1 into R2 divided by R1 plus R2. So what will we get? 3, 5, 2, right, minus 100j, we will get 14 plus 20j parallel to 6 minus 100j. Okay, and now 14 plus 20j R1 R2 divided by 14 plus R1 plus R2, right? So we will get 14 into 6, how much it is? 14 into 6 we will get 84. 84 plus 120j divided by 20 plus 20j minus 100j. Okay, and I'll write this once again here. We'll get 84 plus 120j divided by 20 plus 20j minus 100j. Okay, taking simplifying this one. So I'm going to simplify this and simplify it using table of 2. We'll get 42 plus 60j divided by 10 plus 10j minus 100j. Again, I'll simplify it. We'll get 21 plus 30j divided by 5 plus 5j minus 100j. And now I'll take the LCM, okay? We'll get 21 plus 30j minus 100j into 5 plus 5j divided by 5 plus 5j. And after that, we will rationalize it. So it is 21 plus 30j minus 500j minus 500j square, it will become plus 500 all divided by 5 plus 5j. So it will be 521 plus minus 470j divided by 5 plus 5j. Now I will rationalize it. We will get 5 minus 5j. Okay, so we'll have to multiply it. So we'll get 521 into 5, 2605 minus 2605j minus 470 into 5. Instead of this, we will get 25 plus 25, okay? Four nine 55 minus Okay, I think I made a mistake somewhere. I'll do it once again. 21 plus 30j divided by 5 plus 5j minus 100j. I'll rationalize it from here. 5 plus 5j, 5 minus 5j, 5 minus 5j minus 100j. I'll get equal to 105 minus 105j plus 150j plus 150, the whole divided by 50 minus 100j. So I'll get 105 plus 150, that is equal to 255, and minus 105 minus 150, that is equal to 45j divided by 50 minus 100j. Now I'll take the LCM. We'll get 255 plus 45j minus 5000j whole divided by 50, which is equal to 5000 minus 45, that is 4955. So 255 minus 4955j divided by 50, and simplifying it, we'll get 5.1 minus 99.1j. So this is the answer for Z in. Okay, so this is the final answer. I think there is some problem with the net, so please bear with that. So let's do the next question. Okay, and the next question is, in the below circuit, what will be the value of dVc by dt at in volt per second when t is equal to 0 plus when switch is closed at t. Okay, when switch is closed at t is equal to 0. Right. So whenever these kind of questions are coming, what we have to notice is that before t less than 0, capacitor will be open circuited, and Vc of 0 minus, that is capacitor voltage before the switch is closed and capacitor voltage just after the switch is closed will be the same. Okay, because capacitor will not allow sudden change in voltages, and as well as for inductor, for t less than 0, inductor will act as short circuit, and IL of 0 minus, that is inductor current before the switch is closed or opened, whatever the case may be. So IL of 0 minus and IL of 0 plus, that is will be the same, because inductor will not allow sudden change in current. So please keep this in mind. For t less than 0, capacitor will act as open circuit, and for t less than 0, inductor will act as short circuit. Okay, so please keep that in mind. So okay, in the question it is given that the switch is closed at t is equal to 0. So we'll have to find out what will be the capacitor voltage when t less than 0. So when t less than 0, the switch wasn't closed. So if the switch wasn't closed, this connection is not there. Okay, I'll draw the circuit over here when t less than 0. I have said that when t less than 0, capacitor will act as open circuited. So it will be like this. Capacitor will act as open circuited. So it will be Vc of 0 minus, okay, and 1 ohm. So no current will be flowing over here. So I am not going to draw that because it is open circuited since the switch is not closed. Okay, so Vc of 0 minus. What is Vc of 0 minus? The whole 10 volt will be dropping across our open circuit. So it will be 10 volt. So will be Vc of 0 plus. Okay, so after the switch is closed also, it will be 10 volt itself. So if I am drawing the circuit after t greater than 0, that means after our switch is closed, it will look like this, because the capacitor will now act as a voltage source, because the capacitor voltage will not change suddenly. Okay, that is a basic principle, please don't forget it. These kind of questions, it is very important that to use the concept that capacitor will not allow sudden change in voltages and inductor will not allow sudden change in current. Okay, so that is it, and this time the switch is closed. Okay, fine. And now 1 ohm. Okay. Now let me take the current, this be I1, and let this be I, and towards the capacitor let it be IC. Okay, so I1 is being divided between divided to IC and I. Okay, so IC I can write it as the capacitor current. Okay, capacitor current is equal to I1 minus I. Right. So what is I1? I1 is the current flowing from this terminal to this terminal. Okay, but as you can see, the potential here is 10 volt and here is 10 volt as well. So they are of the same potential. So current will be 0. Current will only flow if there is a potential difference, right? So I1 is equal to 0. And what about I? I is equal to, the potential over here is 10 volt and this is 0, right? So I is equal to 10 minus 0 divided by 1, that is 10 volt itself. Okay, so IC equal to, instead of I1 it is 0 minus 10, that is minus 10 is our current through the capacitor. Okay, now in the question it is asked what is dVc divided by dt. We know that the current across a capacitor, the formula to find out the current across a capacitor is IC is equal to C into dVc divided by dt. This is a formula to find out the current across a capacitor. So we have IC already, which is equal to 10 minus 10 equal to C into dVc by dt. Instead of C I can write 1, right? It is 1 farad. So it is 1 into dVc divided by dt. So dVc divided by dt is equal to minus 10. What is the unit? Volt per second. Okay. So this is the answer. Okay, now let's move on to the next question. So it is given V1 is equal to 5V2 plus 2I2 and I1 is equal to 12V2 plus 5I2. Then which of the following is true? Okay, that is being asked here. So we know that V1 is equal to A V2 minus BI2. So this is Okay, I made a mistake here. So here it is minus, okay. V1 is equal to A V2 minus B I2 and I1 is equal to C V2 minus D I2. It is not plus, it is minus, okay. So V1 is equal to A V2 minus B I2 and I1 is equal to C V2 minus D I2. So this is a formula for ABCD parameters and we are going to compare, we can compare that with this. So A is equal to, instead of A we have 5 and instead of B we have plus 2 instead of that is minus 2, B is equal to minus 2 and instead of C we have 12 and instead of D we have plus 5, that is minus 5, okay. So the answer is 5, B is equal to minus 2, C is equal to 12 and so option number 2. Now let me do the next question. Okay. So this is a next question. Find the value of di by dt at t is equal to 0 plus. Okay, so here also we are going to use the conditions that I told before, that is before t less than 0, capacitor will act as open circuited and inductor will act as short circuited, and the capacitor current voltage will be the same before and after 0 and the inductor current capacitor voltage will be the same before and after switch is closed or open, whatever it is, and the inductor current will be the same after 0 and before 0. This 0 is the time we are considering, okay. So that is it, and using those concept we'll solve this equation, okay. So t less than 0, so when t less than 0, this switch was open circuited, right? So we don't have to draw it. Inductor will act as short circuit and the capacitor will act as open circuit. So this is VC of 0 minus and this is IL of 0 plus, okay. Now we are going to find out what is the current through the inductor. So that is equal to, no current will be flowing over here because it is open circuited. So the current will be 100 divided by 20 plus 20. So which is equal to 100 is the voltage and 20 plus 20 is the total resistance. So that will be 100 divided by 40, that is 5 by 2, okay. So IL of 0 plus will be 5 by 2 ampere as well, because inductor will not allow sudden change in current. And what about the capacitor voltage? VC of 0 minus equal to the voltage across 20 ohm is same as the voltage across our capacitor, okay. So the voltage is being divided between 20 and 20. So applying voltage division principle, we get 100 into total voltage, 100 into 20 divided by 20 plus 20. So we'll get 2000 divided by 40, or we'll get 50 volt, okay. So VC of 0 plus will be 50 volt as well, and with that I'll draw the circuit after the switch is being closed, okay. So if the switch is closed, what happens? this is short circuited. Short circuited means this resistance can be neglected because a short circuit in parallel with a resistance. If a resistor is in parallel with a short circuit, it can be neglected because current always chooses a path of least resistance. Okay, so like that, and the inductor will act as a current source now with current 5/2 ampere. So this is 100 volt, and the capacitor will act as a voltage source with voltage 50. Okay, so this is the circuit after the switch is closed. Okay, now we will find out what is VL, the voltage across our inductor. So the voltage across our inductor, the current through the 20 ohm is 5/2 as well, and the voltage drop across the inductor will be same as 5/2 I into R, right? 5/2 into 20, that is equal to 50 volt. So voltage drop across the inductor is 50 volt, and we know that VL, that is the voltage across an inductor, is equal to L into di by dt. So this is a formula for finding out the voltage across an inductor. So applying that, we'll get 50 equal to, instead of L, we have 1 millihenry, 1 into 10 raised to minus 3 into di by dt. We have to find out di by dt only. So di by dt will be equal to 50 divided by 10 raised to minus 3, or we will get 50 into 10 raised to 3 here ampere per second. Okay, which is equal to 50 k ampere per second. So this is the answer. Okay, with that I am going to end this live session. Rest of the problems I'll be solving and uploading that in my YouTube channel, and the PDF of this solution as well as the other solutions will be given in the will be shared in the Telegram group as well. And the next live will be day after tomorrow, I hope. And I don't know what subject it is. I'll tell what subject. It is it is going to be signals and system. Okay, the day after tomorrow we'll be doing some problems on signals and system, and the rest of the problems I'll be solving as a video and will be uploading in my YouTube channel. The link to my YouTube channel is in my bio. And I'll be sharing everything in the Telegram group as PDF as well. So with that, I'm going to end this video in this live